I have a triangle here where I know an angle and I know two sides, and I'm being asked to find a third, and I have not been given a right angle. So I can't use basic SOHCAHTOA on this because it's not a right angle triangle. But never fear, that doesn't mean it's unsolvable, it just needs a more complicated tool. So we're going to have to use cosine law. So if you sort of ignore this part, you get a squared plus b squared equals c squared. That's Pythagorean theorem. With a tiny little correction on there in case you don't have a 90-degree corner. So how do you use this? Well, you've got to identify which pieces go where first. So the trick is that if this is the angle you're using, the side that goes with it is way over here. They don't touch each other. And you've got kind of a clue in the equation up here. The angle that you're given and the side across from it are literally on opposite ends of this equation. So I'm going to use this as phi. That's this thing here. That goes here because it's the angle or the side across from the angle I'm going to use. And these two sides are interchangeable as A and B. So if I fill in this formula with those symbols, I'll have m squared is, I'll use 11 for A, and I'll use 9 for B. A was 11, B was 9, and I've got cos 36 degrees. Okay, so you've got a whole bunch of numbers there and a whole bunch of work to do with order of operations. So I see an 11 squared here with some adding. The square is going to take precedence over the adding, so I'll do it first. 11 times 11 is 121. 9 squared is 81. And I have some subtractions and multiplications here, so I'm going to do the multiplications first. 2 times 11 is 22. And I have a cos 36 here that I can do. Calculator, cosine 36, 0.809. Okay. So that's not everything I could have done in one line. I just sort of went through and did some steps. You could see how this is going. There's no multiplication happening with these numbers anymore, so I'm free to add them. 121 and 81 would be 202. I've got a 22 times 9 that I could do. Is 198. I'm still going to need to do this multiplication before I can do that subtraction. 198 times 0.809 is 160.182. And 202, subtract that number, gives me 41.818. Last thing to do, I just need to break that square. Now, I'm going to write this in to be technically correct, and then we'll discuss. Anytime you use a square root to break a square, you need to consider both the plus and the minus options. So m is plus or minus square root, that's a cube root, square root of 41.818. Square root of 41.18, 6.47. Okay. So if you've got all the numbers and you just have them on this side, you just have to slowly work your way through the order of operations. And because I do technically need plus or minus anytime I break a square with the square root, I end up with the answer plus or minus 6.47. Now, in the context of a geometry problem, the length of this side can't be negative, right? Negatives aren't allowed for lengths. That doesn't make any sense. So in this particular question, because of context, the length of that side is going to be positive 6.47 units. We have another example here. This time, I have lengths for all three sides, and it's the angle that I'm missing. So the angle is going to go there, obviously. Whatever number, whatever the side length, is not touching the angle in question is the one that goes over here. So if I look across that triangle, I see the 15 is here. So the 15 is going to be my C value, because they are on opposite sides of the triangle, opposite sides of the equation. A and B are really interchangeable, so I'm just going to make 10A and 7B. So I'm going to have to fill in this equation. So 15 squared is 10 squared minus, plus 7 squared minus 2 times 10 times 7 times the cosine of an unknown angle. All right, 15 squared is 225. 10 squared is 100. 7 squared is 49. 2 times 10 is 20. I can do 100 plus 49, that's 149. 20 times 7 is 140. All right, and normally I would just carry on with the correct steps, but I need to point out to you that this thing is a number, and this thing is a number with a letter attached to it. So what you're looking at there is like something like this. A number on its own, and a number with a variable attached to it. But when you see this, you are not allowed to combine those, because this isn't worth 140. It's worth 140 multiplied by some other number that I don't know yet. So it's a very common error to look at this type of thing and say, oh, well, that must be 9x. Well, it is not that. Don't do that. This is a number with no x's at all. So you can't just vanish it and say there's 9 x's left. There's 140 x's and some number that doesn't have anything to do with x. So please don't squash them together like that. So if I'm not allowed to do that, I can't combine these two things because this has a variable and this does not, then I've flipped into algebra at this point. I have to start moving things to the other side. So if I knew that, I would cosine it, then I'd multiply it, then I'd subtract it from this number. So that's the one I have to move first, because it would be the last thing in the order of operations. I'm going to subtract this from both sides. And 225 minus 149 should be 76. I'm just going to check that. Okay. And to finish, I need to divide both sides by this negative 140. And I get 0.543. All right. So I need to arc coast that. And I get 122.87 degrees. Okay. So after doing all that, it's a good idea to sort of check your work. This is going to be the biggest angle in this particular triangle because the triangle's angles have to add up to 180. So there's only like 57 degrees left to spread up between the other two. So this has got to be the biggest one. And the biggest angle has to be across from the largest side. Like by definition, you can't make this really wide and have the side it generates be very small. So it's impossible. So in this particular case, the biggest angle is going to be across from the biggest side, so it all worked out.